So our last video in this unit is going to be about infinite limits and limits at infinity. So an infinite limit occurs when f of x approaches infinity as x approaches a number, okay? So that just means your x is going to be a number and then your y value is going to approach infinity or negative infinity. So the graph approaches a vertical asymptote. This happens most often in rational functions when the denominator equals 0 and the numerator does not. If a function has a vertical asymptote, then it has an infinite limit. So the first one is using a table to find the limit of the function f of x equals 3 over x minus 2 as x approaches 2. So if we're using a table, what I did is I typed it into my calculator, changed my table set, and this is the one I came up with. Just to show you what the graph looks like. So if I'm approaching 2 from the left hand side, so this way, I notice that my y values are getting smaller and smaller and they're going to negative infinity. However, if I'm approaching 2 from the right hand side, so going this way, I notice my y values are getting bigger and bigger, so that's approaching infinity. And the table kind of supports that. So looking at the table now, I see as I'm approaching 2 from this side, my numbers are getting smaller, so it's approaching negative infinity. However, as I'm getting from 2 from my right hand side, I notice it's going 100 to 150 to 300, so those are getting bigger and they're approaching infinity. So since negative infinity and infinity do not equal each other, that means this limit does not exist. So you're looking at from the left side and right side. If they're equal, then that's your limit. If not, it does not exist. The next one, we're going to use the graph of the function of f of x equals 1 over x minus 1 squared to determine its limit as x approaches 1. So looking at this limit, I'm going to type it into my calculator. So y equals 1 over x minus 1 squared. And we're going to take a look at that graph. So now as it approaches 1, I notice from my left hand side it's going up and my y values are getting bigger and bigger. From my right hand side, it's doing the same thing. So as I'm approaching x equals 1, my right hand side is y values are getting bigger and bigger. And the table can support this. So looking at the table and the left hand side limits, I notice as I'm approaching 1, my numbers are getting bigger and bigger, which means it's going towards infinity. As I'm approaching 1 from my right hand side, my numbers are also getting bigger and bigger, so it is also approaching infinity. Notice how both of these are equal, as in they're both the same number, therefore the limit is infinity. So those, you got to look at the table or the graph and see what it's doing. If the graph is going in opposite directions, that's more like your does not exist. If the graph is going in the same direction, then that would be your limit, which would be infinity or negative infinity. So what happens if we're looking at limits at infinity? So what if that means like x is approaching infinity? So we're going to use the graph of the function f of x equals 1 over x to see what the limit is as x approaches infinity. So you're going to go over to your calculator, do 1 over x. Let's look at that graph. So as x is approaching infinity would be this side, because we're looking at the positive infinity. So if I notice, my blue line keeps getting closer and closer to my x-axis, or the value y equals 0. If you're looking at the table, it kind of supports that. So in my table set, I just put 500 because it's approaching infinity, so I wanted to look at a larger number. You could have picked 1,000 or so on. So 1 over 500 is one of my y values. The next one is 1 over 501, and I know that's smaller than 1 over 500. Next one would be 1 over 502, which is smaller than the previous two. So as we're approaching infinity, my y values keep getting closer and closer to 0. Therefore, this limit would be 0. Now we're going to look at the graph of just 2x and see what's going on as that approaches infinity. So as x value is approaching infinity, I notice my y values keep getting larger and larger. So again, I looked at that graph and then the table. So I typed in 500 again. So when x was 500, y was 1,000. When x was 501, y was 1,002. When x was 502, y was 1,004. So if you notice, your y values keep getting larger and larger, which means it's going to approach infinity because it's not going to stop growing. So in letter C, since the numerator is a constant and the denominator is growing towards infinity, we have a very small number over a very large number. So that's why the limit is approaching 0. In letter D, the function grows continuously towards infinity, so that's why the limit is infinite or infinity. Next thing we're going to talk about is infinite limits and rational functions. So recall that a rational function is just a ratio of two polynomials. So f of x equals p of x, which is the numerator, divided by q of x, which is the denominator. Since limits at infinity are horizontal asymptotes, we can use the degree. So remember horizontal asymptotes in your degrees of p of x and q of x to find the limits like we used to find horizontal asymptotes. When calculating a limit as x approaches negative infinity, the sign of the limit can be affected. To determine the sign, we're going to plug in negative infinity and see what you get. So what we're going to do is when the top has a bigger expression, we're going to plug in negative infinity or infinity, and we're going to go through how to do that on your little chart. But for example, if the limit is approaching negative infinity, I would just replace negative infinity. I know negative infinity squared would give me a positive number there, and then I would just simplify. I would get about infinity over negative infinity. Positive divided by a negative is a negative number. The next one kind of shows the same thing. It just shows what happens when it's a different degree. I would get in the end negative infinity divided by negative infinity, which is a positive infinity. So there's three different options here. So if your degree is bigger on the bottom, if your top and bottom have the same degree, or if the degree is bigger on the top. So the first one says if the degree of p of x is less than the degree of q of x. This is just saying the bottom has a bigger degree. So bottom degree is bigger. What that means is your trick is that for any polynomial rational function as x approaches positive or negative infinity, your limit is approaching 0 no matter what. So bottom degree is bigger. An example here would be if you see 2 is bigger than no exponent on top. If you type that into your calculator, you're going to know that your y values are getting smaller and smaller. So we say the limit as x approaches infinity of 3 over x squared equals 0. So of course you can look at your graph or your table and figure it out. This is just a trick. So if the bottom degree is bigger, I know it's going to approach 0. Same thing if it's negative infinity. So if the bottom degree is bigger, it's still going to approach 0 if it's going towards negative infinity. So my limit would be 0 then. So bottom degree bigger, limits approaching 0. Next one is what if your degrees are equal, which means the top and bottom have the same degree. So if the top and the bottom have the same degree, no matter if it's approaching negative infinity or positive infinity, what we're going to do is we're going to take the leading coefficient of both the numerator and denominator and divide them. So an example would be if I'm looking at x approaching infinity here, I notice that my biggest degree on top is x squared, biggest degree on bottom is x squared. Those are the same degrees. So what I'm going to do is I'm going to take the leading coefficients in front of them and divide them. So here, as this limit approaches infinity of this function, I would take my leading coefficient. So 5 divided by 3 would be my answer. You would do the same thing if it was approaching negative infinity. So I look at what degrees I have. So x squared and x squared, they're the same degree. So I know for my limit, I'm just going to take my coefficients and divide them. So here, my coefficients are 5 and 3, and I'm going to divide them. So if the degrees are the same, then you just divide the leading coefficients. So that's case number 2. Last one is, what if the top degree is bigger? So this one is for top degree is bigger. And this one is depending on your leading coefficient value. So if your top degree is bigger, it's either going to go towards infinity or negative infinity. This side here is based off of your leading coefficient, but only when we're approaching positive infinity. Negative infinity is a little bit different, and we're going to go over that, but for positive infinity, it's just based off your leading coefficient. What I mean is, looking at this example, I see that x cubed is my biggest degree on top, x squared is my biggest degree on the bottom, so I know my top has a bigger degree. So to find this limit, I'm going to look at the leading coefficient. So here my leading coefficient is 1. On the bottom here it's 6. Both of those are positive numbers, so it's a positive number divided by a positive number, which would equal a positive number. So I know this would go towards positive infinity. So again, if the degrees on top are bigger, you take the leading coefficient of the top and bottom and see if it's a positive divided by a positive, it's a positive number. If it's a negative divided by a negative, that's still a positive number. If it's a negative divided by a positive number, that's going to be towards negative infinity, and then a positive divided by a negative number is still a negative number, so it's towards negative infinity. So you're just looking at if the leading coefficients are positive and negative, not the actual value. So let's try another one. So as the limit approaches infinity of negative 2x squared plus x divided by 5x minus 3. So I notice on top, biggest degree is x squared. On bottom, biggest degree is just x. So I know it's going to go towards positive or negative infinity because the degree on top is bigger. I just have to decide which one it is. So looking here, I notice my leading coefficient of the top is a negative number. Leading coefficient on the bottom is a positive number. A negative divided by a positive is always a negative number. Therefore, this is going to go towards negative infinity. Now, when it goes towards negative infinity, or when x approaches negative infinity, it has a couple different rules. So looking here, when n is the degree of the numerator and m is the degree of the denominator, limits towards negative infinity can use the following rules. So what it means is, if the degree on top is bigger, what we're going to do is we're going to subtract the top degree and the bottom degree. If it's an odd number, the limit's going to go towards negative infinity. If it's an even number, the limit's going to go towards infinity. So looking at these examples, I notice that my top degree is x cubed. My bottom degree is x squared. So I'm going to do 3 minus 2. 3 minus 2 is 1. 1 is an odd number. So what that means is, as infinity, or as it goes towards negative infinity of this function, I know that it's going to go towards negative infinity as my answer, because odd goes towards negative infinity. Looking at the next one, degree on top is x squared, degree on bottom is just x, so 2 minus 1 is 1, which again is an odd number. Therefore, as the limit approaches negative infinity of this function, I know it's going to go towards negative infinity because when I subtract the exponents, it's an odd number. Just to try one more, as this goes towards negative infinity, again, I got to look at my highest degree. So on the top, it's x cubed. On the bottom, it's x squared. Top is bigger, so I subtract them. 3 minus 2, which would give me 1, which is an odd number. Odd, I know, goes towards negative infinity. So as the limit approaches negative infinity of this function, I know my answer is going to be negative infinity. When you get even here, that's when it goes towards infinity. So that chart is just a fast way of figuring out your limits. So now try the homework. Let me know if you have any questions.